Good morning. Welcome to the online class. So today I'll just discuss about the logic gates. So I have already given you the notes on this logic gates. You know about the AND, NOT, and OR logic, and there are some more logic, that is AND logic, and OR logic, and other logic gates such as XOR gates and XNOR gates. Now, what is a logic gate? So logic gate. So what is a logic gate? So logic gate is an elementary digital circuit that gives the result of the propositional operation. So you need to understand a logic gate is the elementary digital circuit. So you need to understand it is an elementary digital circuit that gives you the result of the propositional operation. So gives the result of propositional operations. Now, so we also have learned in our previous class regarding the syllogism. Syllogism is a process of coming to the conclusion. Okay. Conclusion using the premises of the proposition. So this syllogism means this coming to the conclusion or getting the result of the propositional operation. So different types of logic gates are there. So different logic gates are the AND gates. So elementary. So generally it is a logic gate can be classified into elementary logic gate, elementary logic gate. Under this it comes AND, OR, and NOT. AND, OR, and NOT. This is the elementary logic gate. Then next type is the universal logic gate is there. So in this one, not AND and not OR will come. Not and not OR, it's called AND or NOR. And the third other type is the other type. Here you have XOR gate, XOR and XNOR. So these are the different types of gates. Okay. So now what is the NOT gate? So you know NOT gate is a reverse. Now we need to know the circuit diagram. Now signals that use as inputs and output in the logic gate can be either 0 or 1, and digital circuit is made by using the logic gate. So with the help of the logic gate we can make a digital circuit. So let us discuss about the elementary logic gate. So let me start with NOT. So what is NOT? Now how it is can be represented? NOT gate. NOT gate inverts the input signal to its complement. So if it is 1, it will be 0. If it is 0, it is 1. So like in it's a this one NOT disjunction. That is, it gives the opposite. So NOT gate gives the opposite. Now, if you have two variable P, if you have it works on the single variable. So if you have P is the variable which consists of 0, yes, true or false. Then if you have to do P0, then it will be the reverse of that. So it will be represented in the truth table. It will be represented in this way. Now, how it is represented as in a symbolic form. So So NOT gate is represented as like this, the arrow. Then you have to give this. Now this is P. So P is started, and after this signal it has become P0. So this is represented. This NOT gate is represented in this manner. Now the second one is the AND gate. Now how it is represented? I'll show you. So AND gate. So the truth table. So AND gate. We know that what is AND gate. AND gate means if both the conditions are true, then it returns the true value. So the gate connects two signals using the connectives AND. It implements the operation conjunction. So conjunction operation is joins. It gives the true result only both the inputs are true. So you know the truth table about the AND truth table representing AND. So you know in the same way it will be represented in this. Now if it is PQ, P and Q are the two inputs. We know that 0, we can make a truth table 0 0 0 1, then 1 0 and 0 1 or 1 1. Third one is both are true. Both are false. One is true. Another P is true. Q is true. P is true, and both are true. So when you get the options, so in the AND gate, it will, if it is 0, if both are true, then it returns true. So this is the truth table. Now this will be represented with the symbol this. This is the input P and Q. So we just have to write the input P, input Q. After that, this is the symbol of my hand. Okay, D. Then you just need to give the arrow. Now this is the symbol of AND gate. Now when we combine this P and Q, then it becomes P and Q. So this is the AND gate, representation of AND gate. Similarly, this is the symbol to represent AND gate, and this is the symbol to represent NOT gate. Now let us come to the OR gate. OR gate also same. So we know the conjunction. It's a rule of the truth table of OR gate. So OR gate, third type of gate is the OR gate. So in the OR gate, you need to, if either or, if one condition becomes true, then it is suppose two variable P and Q. So we know that both are false. One is true, one is false, another is true, another is true, another is false. Both are true. So this is the truth table to represent OR gates. Now, if I just have to draw this, now truth table P or is symbol is plus P or Q. Now this will be 0, this will be 1, this will be 1, isn't it? This will be 1 and both are true, this means 1. So this is the truth table of the OR. Now how to represent the truth table? Now it's similar to two inputs are there, P and Q. P and Q are the input, but little the difference of OR and this here, it's this curved one. This one is a curved one, so like this. This is the curved one. So that time this was like D, that was like D. This one end was like D, and this one is the curved one. So curved one, then we can use the arrow. So this represent P or Q. Okay. So this is the logic gate that represents the P or Q. Now this is the category of elementary gates and OR and NOT. Let us come to the universal gate. How it is represented? Universal gates, two types, that is AND OR. So AND gate, the gate involves the signal of AND gates. AND gate, it's a reverse of AND gates. Now we can easily make the truth table Now this comes under the universal gate. There are 3 elementary gates and 2 universal gates. So now let us discuss about the universal gate and AND. And means it is the reverse of AND. So reverse means opposite of AND. So if this is P, this is Q, and P and Q. Another P and Q. Suppose this we take it as any number as D. Suppose we take this as D, AND gates. Now, so we know 0, 0, then 0, 1, false, true, true, false, both are true. Now we know that, we should know that AND gates gives the reverse of the AND gate. And AND gates gives the reverse of the AND gate. So what we have to do, this we know that if it is an AND gate, this will be 1, others are 0, but it is the opposite of that, so this will be 0 and all are true. So this is the AND gates. Okay. Now how to represent, how it is represented AND gates? So it will be represented as like the AND gate but little different. So these 2 inputs are there, input P, input Q. Okay. So it's like a D only, that like AND only, same to AND, but only difference is that you need to put a small round out here. So this represents P and Q, not P, not Q. This gate represent not P, not AND. Okay. So this is a symbol which represents not AND. Now let us come to another symbol, that is OR, not OR. So as the name suggests, not OR means opposite of the OR gate. So same truth table will be there. Two inputs are there. Truth table will make 0, false, 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 true, true, false, and both are true. Now reverse of OR. What happens when you put OR? So when we write P, Q, then this is, okay, let me say this one, 0, 0, 0, 1, 1, 0, and 1, 1. Now this becomes what? If I take OR, either OR means this will be 0, all the rest are 1. Now an OR gates is the invert the signal of OR gate. So this is the symbol OR gate. Now it inverts the symbol, means now this will become, suppose this is C, if it's the OR gate, then it becomes this opposite of that. This is the P plus Q is represented, and this will be opposite of that. That means 0 will be 1, 1 will be 0, 0, 0. So this will be the reverse of the OR gate. Reverse of the OR gate. Now, how it is represented? So same, likewise in little the reverse only. So 2 inputs are there. 2 inputs are there. Sorry, not straight one, it's a curved one. So that we know how to represent OR. So it's an OR gate. But only difference is that you need to put this one. Okay? So after this, you can give the arrow, and this becomes P over Q. Yes. P over Q. That's reverse of this, reverse of this. So it is the inverts the signal of OR gate. So this is the 2 universal gate, that is AND gates and NOR gate. Now let us come to the XOR gate. Now let us discuss about the XOR gate. The other types of gates, 2 other types of gates are there.